All right, on to the trig stuff. So I got a couple down here, and I'm sure everybody's great with your trig, huh? All right, dealing with a problem like this. If you do not have graphing software sitting in front of you, and you don't know how to graph tangent, you're just guessing. You're just rolling those dice and going, let's go with negative. Or positive infinity. I don't know which. But let me tell you, the limits are infinite limits without a positive or a negative on any trig function is never going to exist. Our asymptotes end up going two different directions, but we will have them from the left or from the right. But they'll never exist. Like this right here with any of these trig functions with vertical asymptotes will always be DNE if we don't come from a side. Just by the nature of what they look like. Okay, let's get into it. But before we tackle the problem, we need to discuss something about trig. There's only two functions in trig. Y'all, we've lied to you. We told you that there was tangent. We told you there was cosecant, secant, and cotangent. Nah. Those are some bullshit little tricks that we use to help us shortcut things and we can memorize some stuff. There's only two trig functions. There's sine and there's cosine. And everything else is a combination of the two. Now, tangent is sine over cosine. So, tangent has vertical asymptotes anywhere cosine equals 0. Right? Because if the denominator equals 0, the whole thing equals 0. That's why we create vertical asymptotes. Well, cosine of theta equals 0 when theta is any odd multiple of pi over 2. So pi over 2 is real bad. Real bad. And then we write it with this funky notation, which we say plus pi k. Plus pi k, where k is an integer. Oh my goodness, look at the notation. Don't stress about the notation. What we're saying is any odd multiple of pi over 2 will create an issue. So let's talk about odd multiples of pi over 2. Pi over 2. 3 pi over 2. 5 pi over 2. 17 pi over 2. Negative 111 pi over 2. So if it doesn't reduce down and you got a 2 in the denominator for tangent, that's bad. We mollo. No. Can't have that. So that's why a vertical asymptote's going to appear. Now that we know that, we're like, okay, well, we're going to get a positive or negative infinity, but can you graph it? Do you know what tangent looks like? And if you can't, hate to be a jerk, but you're screwed. you're screwed. So I'm going to give you the shitty graph of it. It's an increasing function. So it goes like this. And then at pi over 2, we have an issue. And then over here at negative pi over 2, we have an issue. But then it just repeats over and over and over. So there's our next odd multiple. And then there's our next one. And it just keeps going forever and ever. It's just, trig. It's like that shit repeats or something like that. So we have vertical asymptotes at all odd multiples of pi over 2. So now that I have the graph, this problem isn't all that tough, is it? Once you see it, but if you can't see it, you're effed. Well, unless you have graphing software and you just cheat your way through things. And again, that'll work out really well when you have to take your tests on ground. Eesh. Yeah, just note to all online students. In fall of 2022, STEM level classes will have on-ground testing. Keep that in mind if you're just trying to get through the course. Okay. So we look at this. The limit is theta tends towards pi over 2 from the right. So we're like, well, there's pi over 2, so we want to go from the right. And we look, and it's going down to negative infinity. Cool. There's the solution. Now let's look over to the right. And this is negative 8 times tangent of theta. Well, I'm going to use one of my frickin' limit laws. I'm going to take that dang negative 8 and I'm going to get it the heck up out of there. So we can just tackle this a little different. So let's just write this a bit different. That negative 8, due to the limit laws, we can just take it and pop it out to the outside and say whatever answer we get, we're just going to multiply it by a negative number. So we end up with that same problem we had on the left, except we're going to multiply it by -8. So we already know it's there, and I can't really write here. So I'm going to write in red, because at this point you just state your answer. I would just state my answer that it's infinity. Because we can never plug in infinity. But do you mind? Don't do this. No, that's not a D. That's an N, right? Okay. Don't ever write this. This is for you so I can show you. Because we're never allowed to plug in an infinity. You plug in an infinity for an X, or like I'm going to multiply by it in any of your work, I will take points every time, because infinity is not a number, it's a concept. But, so I'm going to do this just for the visual. Didn't we already find out that this was negative infinity? Yeah? Yeah. Okay, so here's the bad thing, which you're never allowed to do, but I'm just showing it to you. So we have what's a negative number times a negative number? Isn't that positive? Isn't that positive? That's positive. Now, 8 times infinity is nonsense. That's dog times cat. But we can kind of think of it this way. In my brain, I think of it. You know what 8 times infinity equals? Infinity. You know what 3 plus infinity equals? Infinity. You know what infinity times infinity equals? Infinity. We're only looking at the signs. And everything I just said is nonsense. You cannot multiply infinity by something, but we can get the concept. So since we're just multiplying it by a negative number, it would turn into something positive. But once again, don't ever do this. Plugging in infinity is nonsense. It's like I'm going to plug my phone into a math problem. You're like, what the frick does that even mean? It doesn't go together. So that's what's happening here. Look at all this nonsense I have written. So we move on. Make this one a little bit longer. Let's see if we can tackle this one. The limit, let's say x is tending towards 0, and this time, let's make it cosecant of x. And remember from before, there is no such thing as cosecant, secant, cotangent, or tangent. These are just combinations of sines and cosines. So for y equals cosecant of x, that is y is equal to 1 over sine of x. So there's only 2 things you have to know. You have to know the ones that divide by sine, and you have to know the ones that divide by cosine. There's never going to be divided by anything frickin' else. So sine of x equals 0 when x is equal to any multiple of pi. Sorry for the notation at the end. That just means k is an integer. You know, 1, 2, 3, 4, -1, -2, -3, -4, or 0. So let me list some of the things. 0, 1 pi, 2 pi, 5 pi, -8 pi, -7 pi, -13 pi, +13. It doesn't matter. If you're plugging in frickin' a pi into sine, it's 0. Or if you plug in 0 pi's, that's a multiple of pi. It equals 0. Thus, we have a domain issue here. As always, it's the whole frickin' class, right? You're like, when are the domain issues going to end? 3.3, that's when that shit'll end. So now, can we draw it? We know there's a vertical asymptote, and if you can't draw it, you're just rolling the dice again and being like, I don't know. So we got to look at it. Let's go. Let's go. Now, we have problems at a certain amount. So pi is bad, 2 pi is bad, 3 pi is bad, -pi is bad. Oh, shoot. You know what else is bad? No freaking pies. 0 is bad. So we have vertical asymptotes at all multiples of pi. Now, this is the way it looks. You remember this from trig or pre-calculus, don't you? It's okay if all you... Oh, whoa, I made that one too high. And all of these heights right here, this is at 1, 2, and these down here are at -1. But by looking at the dang graph, It makes it freaking pretty simple, doesn't it? We're right back to that first freaking section where I gave you the damn graph. So we look at it, we're like, well, what's the limit of cosecant of x as x tends towards 0? Dude, it's going to infinity. But notice that with all the trig functions, we have to have a plus or we have to have a minus, or it'll never have the limit. Did you notice that if you come from the left, it's going down to negative infinity? On any of these vertical asymptotes. Same thing with the tangent functions. Oh, okay. So there it is. Sorry for the long video, but I know trig can sometimes be a real sticky thing for us. So, good luck, y'all. See you in 2.5.